Okay, so our goal states that we have to determine a plan that will allow a reader to create two exponential functions that, once they're multiplied, will create a new function where it'll have a y-intercept that's a multiple of 5. It has undergone a horizontal compression and it's a decreasing function, so it's showing a decay. So I've gone ahead and already came up with functions. This video will just be me running through the plan and showing off what I've done as far as solving it and add my little critiques and stuff on the actual carrying out of the plan. So as far as step one, that looks pretty good. Basically goes with the requirement stating that we need to have a y-intercept that is a multiple of 5. So all it basically asks us to choose an a y-intercept that is a multiple of 5 for the first equation. Um, Now interesting here is that it says that it doesn't have to be a multiple of 5 yet, but it'll make more sense if it is. Now, from reading the question and from reading the plan, that definitely makes more sense. But if that's the case, I don't really think that you would need to state that you have to pick a multiple of 5. It's a good recommendation, definitely, but I think it would be better off if you went with step 1 and 2, put them together and say pick any number for the y-intercept, provided it's something like maybe an integer or a real number. I'm not sure. It's pretty vague. It just says pick any number. Also, there's no real reason why it says that it doesn't have why um, in the plan it stated that it doesn't have to be a multiple of 5. Maybe this is in the conclusion. I'm not sure. If it is, cool. If it isn't, I think either way you'd just be better off if you had that up here as far as in the plan. Um, Step 2 again just says to pick any y-intercept. Here it's specified that it has to be an integer. I think that'll be better off, like I said, if you combine the two steps and stated for both y-intercepts that it had to be an integer. Just a little easier to understand. Um, I like that you have two possible pathways for solving it. Um, I went with the second method where we would have different bases. So I skipped right to step 8. It says since you want different bases for the two equations, choose a horizontal compression value that is the same for both equations. Well, if you just go quickly to the equations I came up with on Desmos, the first two here are those. As you can see, the horizontal compressions are the same. Both have a horizontal compression of 6, and as you said, it will be reciprocal. So when you actually do the math, it'll be so to the power of 1 over 6. So that does work. It matches the requirements. Good explanation here. Must be over 1, like I said. So you're using the reciprocal as far as solving. Step 9 here. Now you choose your bases, basically your parent functions. It says here that it has to be greater than 0 but less than 1, so it's got to be a fraction, showing a decay. That's good. Couple things here. Actually, I think the only thing here is just the main form for the exponential function. F of x equals a times b to the exponent cx. Um, I don't know why there's no horizontal shift. It's part of the base, it's part of the whole standard function for an exponential function, so I don't know why you're totally ignoring shifts and translations. Again, that's probably in the conclusion, but I think that definitely would be something to add since that's something that I think most people would be looking for. So, as you can see, as far as the equations I came up with, that's the same. Different bases, you can tell 1 over 4 for equation 1 and 1 over 3 for equation 2. Now we're at step 10, which simply says to multiply them, and we have a new exponential function that meets our requirements. So we have 3 requirements, multiple of, and I came up with the equation 70 times 1 over 12, so the exponent's 6x. Now, does it meet all the requirements? Is 70 a multiple of 5? Yes, it is. 1 over 12 shows a decay. It's a decreasing function. We have a horizontal compression. And if you look at it visually, it does work. Now, as you can see, it's looks like it's directly on the line, but if we zoom in, there we go. We have an exponential decay. If you do go up, I'm not going to go up all the way because I would basically have an a y-intercept, sorry, of 7. But I did look at it and it does make sense. And as far as the parent function, there was a restriction for the parent function. New base, however, the horizontal will stay the same. Yep. Parent function here just in case. So that shows off the horizontal compression. So overall, I'd say the plan works. Few specifications here and there, and from what the reflection says, basically saying that it does. Now it says the reason that the basis for one method must be the same is to make sure that you can actually multiply the two functions, as was stated by the exponent law. Yeah, definitely follows the exponent law. The other method is also an option since the bases are different, however the exponents are the same. Yeah, it did work. So no real laws to confirm it as far as exponent laws or anything, but it definitely worked. Also, it is possible for the function's horizontal compression to be negative. However, if that were the case, it would change from an increasing function to a decreasing, or a decreasing function to an increasing one. Yeah, definitely. As far as my computer went off. But from what I got from it, it definitely works. I've read over it a little, and it does take into account stuff like horizontal shifts and compressions. I just think that might be something that you might want to add into as far as the actual plan. Besides that, good job. It works, and yeah, that's it.